Yeah. So hello everyone. hmm Anyway, so let's get started. Mm, Yeah. So let's start with the PYQs of application of derivatives. My my voice is quite down today because my mood hasn't been good. Specifically, I think my productivity is going down. But anyway, that's my personal problem. I shouldn't bring that here. PYQs of AOD. So we will go. So basically, the plan is we will go to the PYQs which are from the JEE Advanced level. Okay. Specifically, we will do PYQs of maxima and minima. Okay. Specifically, we will do PYQs of maxima and minima. Why? Because again, they are the backbone of derivatives. Basically, if you are able to calculate, if you are able to solve AOD questions of maxima and minima, the rest of the questions will follow because all the questions actually utilize the concepts of maxima or minima. For example, calculating tangent, you need to know how to calculate the derivative, which you can again use in the calculation of maxima minima, calculation of rate change. Okay, so stuff like that, even in Rolle's theorem. So let's get started. So a little bit about myself before we get started. This is me, Saurabh, your mentor. I am an IIT-JEE graduate. I have graduated from IIT-JEE this year, 2020. I'm an electrical engineer by profession. I mean, I did study electrical engineering, but I did not like it, so mostly I studied artificial intelligence and quantum computing while I was actually there. So IIT gives you a lot of leeway, how you would like to prepare and how would like to you would like to study. So you have to do some courses which are from your core department, electrical, and rest of the courses you can do whatever you want. So in that case, if you want to try multiple things while you still are in IIT and think that okay, this stream that I have chosen is actually not for me, then IIT is a very good place. So work profession, I have worked for Nokia and Yahoo previously. On top of that, I have 4+ years of teaching experience. I have taught and mentored a lot of people for their CPSC, NEET, and JEE, of course. I've also mentored a lot of people who are inside IIT itself. So basically, career guidance and job counseling, etc. Anyway, I hope I'm audible. Let me just check my volume. Okay. Yeah, it seems I'm audible. Anyway, let's crack IIT-JEE with Unacademy, yada yada yada. Okay. So this is a general funda. Basically, an academy aims to provide you with high quality education. That's why they hire people like us who are very expert in their own fields. This is regarding the plus subscription. Okay. In the plus subscription, you will get daily live classes, live tests and quizzes, structured courses which would be prepared by people like me, and unlimited access to all the materials. Okay. You can download the Unacademy app from Google Play Store. Oh, fine. So this was the I shouldn't bring it here. So this is the new fee structure. I'm sorry, that was the old fee structure. Okay, I should have taken it out. This is a new fee structure. New fee structure. This is applicable from 10th of September, so from yesterday. So now for 2 years, earlier fees was 36,000, but now the fees is 56,000. Okay, maybe I'll change it in the next lecture. I apologize, I forgot it, but just remember this is a new pricing scheme that you should focus on. This is the old one. Okay. On top of that, you can get 10% discount. So in order to avail that, I would like you to use this promo code SK01 to if you use this promo code SK01, you will get 10% extra discount on your any subscription that you would like to take for 1 month, for 3 months, for 6 months, for 1 year, or even for 2 years. Okay, seems legit. Now let's move on. So I guess it's a pretty good deal. 1 month for only 7,000. I mean, this is way cheaper than a coaching center, and you're getting a lot of variations. You're getting thousands of educators from which you can choose which subject you want to study from, which person. You're getting a lot of free courses. It's also live classes. So I guess it's a pretty good deal in 7,000 rupees. JEE Advanced PYQs Maxima and Minima. As I told, mostly I will be focusing on Maxima and Minima. Most of the questions are from JEE Advanced. Mostly, I say, I promise you, all of the questions are from JEE Advanced. Okay, all the questions are from JEE Advanced. So I guess it's better to do. Previously, we have done JEE Main Maximum Minima questions, and I think it's obviously straightforward, and it's quite obvious that we should do some JEE Advanced questions also to see what are the extreme applications that could be asked in JEE papers. Okay, so let's get started. I guess this question we did in the last class, or we didn't. Yeah, I guess we did not do this question last time. Anyway, so let's try to do this question. This is a question asked in JEE Advanced 2016. It's pretty sad that no one is watching my lecture. I mean, either way, this, I know I'm getting paid, but it would motivate me if people are actually watching this lecture. I guess it's because that this YouTube channel is quite small, so I would request all of you to subscribe if you actually end up liking this video. Okay. So the question is as follow. By the way, this was asked in JEE Advanced 2016. I gave JEE Advanced 2016, and I was selected in JEE Advanced 2016. And to be honest, this question was really non-trivial at that time. Okay, and I made a couple of mistakes while attempting it. For example, first I saw this question, I thought that okay, this question must be from the concept of quadratic equation, because I saw 4 alpha x square plus 1 by x, quadratic equation or cubic equation, basically cubic polynomials. So I made it a cubic polynomial, and then I tried to solve it. Okay, I want to make sure that a cubic polynomial is always greater than. So this is what I actually tried to do, and that's a pretty stupid thing to do, I have to say. 4 alpha x square x cube plus 1 is greater than equal to x. This is what I actually tried to do, and this actually led to 4 alpha x cube minus x plus 1 greater than equal to 0, and this is the value that I got. And I was like, okay, this is a cubic polynomial, and this polynomial has to be greater than equal to 0. Now what I actually want, so I did a lot of calculation, basically sum of roots, product of roots, and then I thought maybe I could solve it that way, but that was not the very good way to solve it. Anyway, so today we'll see how to actually solve this question, and that will make a lot of sense this time. Anyway, so let's get started. So basically just see that the polynomial we have been asked is this. So basically we want that if this function is fx, we want that fx should be greater than equal to a number 1. Okay, this is what we want. We want that the this function should be greater than equal to 1. Okay, now let's try to understand one thing. You should know that this is the property of minima. That minima, that a function is always greater than equal to the minima of that function. I mean, that's obvious by definition. So by definition you see that a function value is always greater than equal to its minima value. That is the definition. Minima value is the value which is minimum. So rest of the values will obviously be greater than that minimum value. Okay, so for example, if you see a graph like this, if this is the minima, all the rest of the values are obviously greater than this minima value. Okay, so we want that function fx is greater than equal to 1 for all x. Okay, now just try to understand, if we show that minimum of fx is greater than equal to 1, if the minima is greater than 1, then rest of the values will obviously be greater than 1. What I mean is, if the minima is greater than equal to 1, rest of the values which are obviously greater than minima, so they will obviously be greater than 1. You see, I have mixed this and this inequality. Okay, so we would like to show that if we could show that minimum of fx is greater than equal to 1, it would imply that fx would be greater than equal to 1, because fx is already greater than minima. If fx is greater than minima, fx would surely be greater than 1. Okay, so this now becomes a question of maxima and minima, and we would like to calculate the value of maxima or the minima. Okay, so let's try to do it. Anyway, so now if we would like to see, we have a function which is you take the derivative to calculate the minima. You will get 8 alpha x minus 1 upon x square for minima f dash x is equal to 0. It would imply that 8 alpha x should be equal to 1 upon x square. If you solve it, you will get 8 alpha x cube equals 1. X equals the point. Okay, now if you do this, you will get x equals 1 over 2 alpha to the power 1 by 3. So this is the point of minima. I will again show the questions for people who have just joined. This is the question. We are doing question of JEE Advanced 2016. The least value of alpha for which this equality holds true. So we said that we want to, let's say this is a function fx, and we want to show that this is greater than equal to 1. Now I said that the function is a function, any function is always greater than equal to its minimum value. So if we could show that the minimum value is greater than 1, then the function will obviously be greater than 1. Okay, if the minimum value is greater than 1, then the function will obviously be greater than 1. Okay, so let's try to do it. And so this is the x, this is the point of minima. What is the minimum value? You see, you put this down to fx, so you will get 4 alpha square plus 1 over x, which is inverse of this. It would be 2 alpha 1 by 3. If you solve this, you will get 4 alpha into 1 by 4 alpha to the power 2 by 3. If you solve this, you will get alpha to the power, this is 1 2 by 3, alpha to the power 1 by 3 plus 2 alpha to the power 1 by 3. It implies 3 alpha to the power 1 by 3. Okay, this is the minimum value. This is the minimum value, and we want that this minimum value is greater than equal to 1. So if we solve it, we will get this. Which should imply that alpha is greater than 1 upon 27. So least value of alpha 1 over 27. Okay, maybe I'm writing too small. I should increase my, because on the screen it looks very small. Anyway, so I hope this is clear. One of the other ways to solve this question would have been that you solve this and you get something like 4 alpha x cube, minus x plus 1 greater than equal to 0, you assume this as function and you calculate the minima then. So we can also try to do that. So if you differentiate this, you will get how much? 12 alpha x square minus 1 equals 0. So you will get alpha to be equal to 1 upon 12. Sorry, you will get x to be equal to 1 upon 12 alpha to the power half. You will get plus minus and one value will be corresponding to maxima, one would be minima. Okay. So if you put this value down here, you will get 4 alpha 1 upon 12 to the power 3 by 2 alpha to the power 3 by 2 minus 1 upon 12 alpha to the power 1 by 2 plus 1. Now if you solve this, this will become fairly complicated. So I guess this is not the very best way to do. So the better way to do it, actually leave it as it is and then solve it. Okay. Generally, whenever they give you a question in JEE Advanced, you don't have to apply any kind of manipulation. Read the question as it is. Okay, it is already in a very simplified form. So whenever they give you a question in JEE Advanced, don't try to apply a lot of, how would I say, a lot of manipulation on it. Try to reduce it, get it to a better form, because I guess most of the time you will get the answer from the actual form only. This is what I have experienced and see. Anyway, so am I even audible? It seems I am. Okay. So the next question is of JEE Advanced 2013, and the question is as follows. The question is the number of points in minus infinity to, oh nice. Okay. So try to do this question. The number of points in minus infinity to infinity x square minus x sin x minus cos x. So Dhruv, am I audible? Like मेरी आवाज आ रही है तुमको? Anyway, try to do this question. The number of points in minus infinity to infinity for which x square minus x sin x minus cos x equals to 0. We are doing previous year questions of maxima and minima specifically for JEE Advanced. All the questions are from JEE Advanced. Okay, it seems like I have given too much time. Let's try to solve it. Okay, so this type of equation when you have a trigonometric plus algebraic expression in one equation. Okay, when you have a trigonometric plus algebraic expression, you call it transcendental equation. Transcendental. Yeah, this is a spelling. Yeah, so this is a transcendental equation, and generally they ask, I know they can be pretty tough, but people ask such questions in JEE and find equation number of solutions of a transcendental equation. So in that case, what you have to do is you have to separate it in different parts. Okay, different parts that you see are possible. For example, this could be written as this: x square x sin x plus cos x. This we are very familiar with. Okay, and remember, this such kind of question are only solved using graph. You have to make graphs because you will never get perfect value. हाथ से ऐसे सॉल्व करोगे तो वैल्यूज से नहीं निकलेंगी, ठीक है? Anyway, So yeah, one of the solution is obvious. If I put x equal to 1, no. Anyway, so just try to see it. We will draw the graph of this 1 and 2 separately, and then we will see at how many points do they intersect. Okay, so first you have y equal x square, y equal x square. Pretty simple. The graph looks like this. Okay, but the other one is we have x sine x plus cos x, and we have to draw the graph of this. So I'll tell you how to draw the graph of complicated function like this. So first you have to understand that we will draw the graph of this and this. Cos x, we know how to draw the graph of cos x. We just don't know how to draw the graph of sin x. I'll tell you how to draw the graph of x sin x, then we will join them together. Okay, try to understand that sin x lies between 1 and -1. This all of you must know. Now if you multiply both sides by x, so we are trying to make the graph of this. If you multiply both sides by x, you will get x sin x should be between x and -x. Okay, now this is how you draw the graph of x sin x. You draw a line like this. Okay, you draw y equal to x, which is something like this. This is y equal to x. Then you draw y equal to -x, which is something like this. And here you draw a sine function, but the sine function limits would be this: y equal to x and y equal to -x. You see, x sin x will lie between x and -x. So x sin x will lie between these two graphs. So if I try to draw it, it would look something like this. Sine function, simple. The nature is sine, but it is kinda elongated. Okay, and these points are the same points that you know. This would be pi, this would be 2 pi, 3 pi, 4 pi, 5 pi, etc. But you see the nature now is somewhat like it's sine wave but elongated, and the elongation goes from +x to -x. Similarly, on the negative side, you will have to make a sine function, but understand, if you have a sine function and x is already negative, so you have to flip it. Okay, so you just have to take a mirror image. Remember, if you simply draw a sine function on the left hand side, that would not be good because you have another x which is negative. So you will have to draw it again as a flipped version, which is nothing but the mirror image. Okay, so this is the graph of y equals to x sin x. This is the graph of y equals to x sin x. Remember? So this is the graph of y equal to x sin x. Now what about y equal to? Now we also have to draw y equal to cos x. And y equal to cos x is quite simple. This is y equal to cos x. Okay, this is y equal to cos x, and now we want to add these two. So just try to remember that y equal to x cos x lies between 1 and -1 only, but this can go up to -infinity and plus infinity. So you have to understand that this will dominate. Okay, dominate as in the nature will finally be like this, not like this. Okay, so understand that at x equal to 0 the value is 0 here, but at x equal to 0 the value is 1 here, so this will shift to 1. So the final graph will look something like this. At 0 the value is 1. Which one? What's your question, Ariman? X sin x, how? Do you want me to explain how did I get the graph of x sin x? Is that your question, Ariman? Okay, so meanwhile if I remain answers, let me just add these two. Okay, so if you try to add these two, you will get something like this. So the nature will be same. How the graph will dominate, see how the graph will dominate, it means that the value, this can take value. So for example, cos x will take value between 1 and -1. Okay, x sin x will take value from x and -x. Now if you add these two, you will see that cos x plus x sin x will actually take value from x plus 1 to -x plus 1, something like that. So you see the nature is again between two lines, x plus 1 and x minus 1, x plus 1 and minus x plus 1. So basically the nature will again be something like this between two lines. Okay, so you would see, this is what I mean by domination. Domination means dominate, one graph dominating others means that the nature of the final graph would be like this. Okay, it won't be like this. Okay, because you see that this graph can actually go to plus infinity and minus infinity, but this will only go to 1 and -1. So eventually if you add even 1 to plus infinity, the value would still be close to infinity, which means the value would still be whatever the value of y is equal to x sin x was. Okay, this is what I mean dominate, because it means that the value would be closer to what actually the value of y equal to x sin x actually is. Okay, but when I am near 0, then we will have to be careful. So you see that at x equal to 0, this value is 0. At x equal to 0, this value is 0, and this value is 1. So we'll have to add them both, and this is how you will get the graph. The graph will look like this. At 0, the value is 1. So starting from 1, then it will go upward. Upward, why? Because you see this nature. So it will go upward. Okay, then downward, then upward, then downward, then upward, then downward, and it will keep on increasing. Okay, I have not made it exactly scale. Okay, let me draw it with scale, otherwise अच्छे से समझ में नहीं आएगा. Okay, so this is the graph. Fine. And the original question was to find the number of solutions of x square minus x sin x minus cos x, which we wrote as x square equals x sin x plus cos x. Now we have gotten the graph of this. We know the graph of this. We plot them both and we see the number of intersections. Okay. So this is the graph of y equal to x square. Now if you plot the graph of y equal to x square, it will look something like this. Okay, this is a graph of y equal to x square. It won't touch these points, it will touch at exactly 2 points. Remember, this will touch at exactly 2 points. Fine. So this is how you will get the number of solutions, and the number of solutions would be 2. See, this is easy to see. If you see, अगर तुमको लग रहा हो कि वो इधर टच करेगा, you just verify it. Y equal to x square. If you take the derivative, y dash is equal to 2x. Okay, y dash is equal to 2x. At x equal to 1, the derivative slope is 2. Or you can simply, I can tell you a better way to actually verify it, at how many points it will cut. See, I know कि ये y equal to x square का जो कर्व होता है वो कुछ ऐसा ही रह जाता है. Okay, anyway, that thing you don't have to remember, but अभी के लिए बस याद रखो that in that case it will intersect at only 2 points. Anyway, so सिर्फ 2 पॉइंट पे इंटरसेक्ट करेगा. Number of solutions are 2. चलो ठीक है, अब आगे बढ़ते हैं. वैसे मैं भी एक बार वेरीफाई कर लूँगा कि 2 होंगे या 4 या 6 भी हो सकते हैं, but because I already know the answers is 2, so I am emphasizing on 2. बट मैं एक बार खुद से वेरीफाई भी करूँगा कि आंसर 6 भी हो सकता है क्या, क्योंकि ऐसा भी तो हो सकता है कि वो पूरा ऐसे टच करके निकल जाए. अच्छा, ओ नाउ आई अंडरस्टैंड y इक्वल टू x स्क्वायर है ना. I got the answer. Actually, a graph would be like this. Then actually it will have two solutions only, not many. ठीक है. Yeah, fine. So let's move on to next question. So this is your next question. It was asked in JEE 2010. Question number 3, I guess. If you're liking the video, at least subscribe कर देना channel को. The channel is still growing, and the educators are giving their best to actually make this channel grow. So subscribe कर देना. चलो, so let's try to solve it actually. Let f, g and h be real valued functions defined on the interval 0 to 1 by fx equals e to the power x square plus e to the power minus x square. Okay, so f, g and h be real valued function defined on the interval. So this is the interval, and we have been given three functions: f, which is e to the power x square plus e to the power minus x square. Okay, the second function is x e to the power x square plus e to the power minus x square, and the third function is x square e to the power x square plus e to the power minus x square. And we have been asked if a, b and c respectively are the absolute maxima of the three functions. So a, b and c are absolute maxima. Absolute maxima is obviously defined in an interval. So in 0 to 1, they are the absolute maxima. So first we have to calculate the absolute maxima, and then we will see are the absolute value. What is the relationship between the absolute maxima? If a equal to b or c not equal to b, or a equal to c or a not equal to b, something like that. So let's try to do it. The first thing you have to keep in mind is you calculate the derivative, and then you actually see what are the points of maxima or minimum. So let's take the first function. We take the derivative. It would be 2x e to the power x square minus 2x e to the power minus x square. You take 2x common, you will get e to the power x square minus e to the power minus x square. Now realize that if you put it down to 0, you will get two solutions. Either 2x is equal to 0 or e to the power x square equal e to the power minus x square. Both will have a single solution. If you solve this, you will get x equal to 0. This will only be true if x equal to 0. Otherwise, it won't be true. Okay. So at x equal to 0, we understand that this function will have a, if you just take a double derivative, you will get, so if you take a double derivative, you will see this would be 2x square e to the power x square, and this would be 2x square again e to the power minus x square. Now if you put x equal to 0 here, you'll get you'll see that the double derivative also turns out to be 0. Similarly, the triple derivative also turns out to be 0. But anyway, since 0 is the end point, we expect that there won't be any kind of, we don't want to find any kind of maximum or minima at the end point also, and at the end point. Okay, but you would see that otherwise, if you ignore the x equal to 0 point, if you ignore the x equal to 0 point, otherwise the derivative is always positive in the interval 0 to 1. In the interval 0 to 1, the derivative is always positive. Why did I say so? Let's have a look at this. You can write this as 2x e to the power 2x square minus 1 upon x square. Okay, now understand that this is always positive in 0 to 1. This is always positive in 0 to 1, not including 0 exactly, because at 0 this is a point of inflection probably. So we don't have to worry about at x equal to 0. But when we are finding the global maxima or global minima, we have to look inside the interval, not at the endpoints. Okay. Now you see e to the power 2x square minus 1. Can it be negative? I am claiming that this is always positive. We can simply, for this is always positive for all x belonging to 0 comma 1. You can simply verify it. You basically you know that e to the power 2x square will always be greater than 1. This is always true because you see this is the exponential curve graph. At 0 it has a value 1, and after that it keep on increasing. So the value 1 would be attained at x equal to 0, and after that the value e to the power 2x square will obviously be greater than 1. So e to the power 2x square minus 1 would always be positive. So we have gotten that the derivative is always positive for all x belonging to 0 to 1. What does it mean? That function is always increasing in 0 1. So we have gotten the first function f is always increasing. Now similarly you try to do this with second function and third function. You will see the similar kind of result. Second function is x e to the power x square. This is g. Okay, this is g. So you take the first derivative. You'll get x square. So you have to apply the chain rule here. Anyway, you can again simplify it as e to the power 2x square 1 plus 2x square minus you can write it as minus how much 2x upon, yeah. So this is how you can actually write this final expression. Or if you do a little bit of simplification, you get e to the power 2x square plus 2 e to the power x square. I'll take 2x as common. X e to the power x square minus 1 upon e to the power 2x square. Now my claim is this whole quantity is greater than 0 again. Only for x equal to 0 this will attain a value of 0, otherwise this quantity is positive again for all 0 to 1. You can verify it. एक बार आराम से verify कर लेना, हो जाएगा बहुत पैसे. देखो this quantity is always positive, so you only have to worry about the numerator. This quantity is always greater than 1. You proved it. Okay, now x e to the power x square, if you put 0 this would be negative, but this would be close to 0. You see this function would be always less than 1 in 0 to 1 at least. Okay, and this function would be always greater than 1. Anyway, so both of these are positive. The main thing to understand is this and this both are positive, because see e to the power x square will obviously be greater than 1. But x e to the power x square, would that be greater than 1? No. So this would become negative. This whole thing can become negative, but again the negative value won't exceed 1. एक बार verify कर लेना. So this whole quantity would be positive. So numerator positive, denominator positive. Or is it another? Is there another way to verify it? I guess there is. See, this is a decreasing function. This is a decreasing function because e to the power minus x square is decreasing. So this value would be maximum at 0 and minima at. So this is a decreasing function, which implies minus 2x e to the power minus x square is an increasing function. So the maximum value would be at 1, and the maximum value would be 2 into e to the power minus 1, which is 2 upon e. This is less than 1. So the maximum value of this guy is less than 1, and this guy is always greater than 1. Always. So obviously the difference would be positive. So in that, from there also we can say that g dash is always positive. Similarly, you can verify that h dash is also positive. So we get that all the functions which we have here are positive, which means strictly increasing for all the values in 0 to 1. which means they will attain their maxima at which point? At x equal to 1, because they are strictly increasing, and increasing function will attain its maxima at the endpoint only. So at x equal to 1, the maxima of this guy would be equal to e plus e inverse. This would also be e plus e inverse, and this would also be e plus e inverse. So you see a, b, and c all are equals. The answer is D. A equals b equals c. So basically the tricky part was to verify that all of the function are actually increasing. And if you use your head simply, you can verify it. So I'll just show once again how did we verify this function to be always positive. Yeah, so I said that you see this function 2x e to the power minus x squared. X squared is a strictly decreasing function, x is a strictly increasing function, their multiplication would be strictly decreasing. I guess so. If you take the second derivative, yeah, their derivative is coming out to be negative, so it would be strictly decreasing. If this function is strictly decreasing, with the negative sign it will become strictly increasing. It means that the maximum value of minus 2x e to the power minus x square will come at how much? Come at, because this function is increasing, so the maximum value will come at x equal to 1. That would be equal to minus 2 upon e, which is again less than 1, and this function is always greater than 1. So greater than 1 minus less than 1 is always positive. Anyway, so that's how we prove. So let's move on to the next question. This is the next question: the total number of local maxima or the total number of local minima of the function. And if you are watching this video and you like the lecture, subscribe कर देना channel को. इतने फालतू के educators are really trying their best to make this channel grow. Anyway, so if you get the answer, comment the answer in the comment section. Okay, this is the JEE Advanced 2008, IIT-JEE 2008. I'm giving you a few minutes. Try it on your own, then we will solve it. Okay, so let's solve it. So the question is the total number of local maxima and minima. So basically you have to calculate local maxima plus minima, and you have to report the final number. First you have to understand that this is a piecewise function, and there is one thing about piecewise function: you cannot go with the standard method to calculate the maxima and minima. The standard method to calculate maxima and minima is you take the first derivative, take it to 0, then you take the second derivative and you check whether it is less than 0 or greater than 0. This is what you do. But in a piecewise function you cannot actually do it, because it is not guaranteed that the derivative will exist, especially at the endpoints, especially at the points where the function breaks. So in those cases you have to draw a graph. We would like to draw the graph of this function, and then we will see how many local maxima or minima it has. So if you see, the function is divided into two parts. The first part is 2 plus x whole cube, and the second part is x to the power 2 by 3. Now this is valid from minus 3 to 1, and the other one is valid 1 to 2. Okay, this is how it is. Fine, so we would like to draw the graph of this. So first we have to draw the graph of this function. So first we'll say, okay, let's try to draw the graph of 2 plus x cube. Okay, this is a cubic polynomial, and what about this cubic polynomial? It has only one root. and that root is x equal to -2. सर इस बायोलॉजी इनफ, बायोलॉजी जी एडवांस में क्या आता है, थोड़ा आता है, क्या बोल रहे हो, बायोलॉजी इनफ okay, maybe some joke message. Anyway, so 2 plus x cube, it has only one root and that is x equal to -2. So the graph will look like this. Standard cubic polynomial -2, the graph will look like this. Okay, this is how the graph will look like. This is y equals to 2 plus x cube. Okay, and the other one is x to the power 2 by 3. We have to draw the graph of this guy also. Now understand that you know the graph of x square. The graph of x square look like this. Okay, now I'll tell you some important stuff, and the stuff is, maybe I'll have to take some sheet. Let me take another sheet. So the stuff which I am going to tell you is how to draw the graph of x to the power 2 by 3. Remember that x to the power 2 by n, where n is odd, such kind of graph will have a nature similar to y equal x square. Okay, so such graphs will have a nature similar to y equals x square. So y equal x to the power 2 by 3, the graph will look something like this. So this is the graph of y equal to x to the power 2 by 3. Fine. Now you have the graph of x to the power 2 by 3, you have the graph of x to the power 2 plus x to the whole cube. Now what's left is to join them. So this is valid from -3 to -1. So this is -3 and this is -1. Okay, and this is valid from -1 to 2. So let's try to join them both. If you join, if you make the final graph look like this. First the component of the cubic function. Okay, at x equal to -1, you see this value is 2 plus -1, which is 1. 1 cube is 1. Okay, so this value is 1. At x equal to -1, the value of this guy is also -1 to the power 2 by 3, which is also 1. So it will join from here only. And so it will join from here. Okay, so this is how the graph will look like, and this I have to go only up until 2, and this is -1, -3, sorry. Okay, so now if you see in the entire graph, you can omit this portion. Okay, so now वॉइस इज नॉट कमिंग, कोई बता क्यों नहीं रहा था फिर मुझे. अभी ठीक है ललित. Anyway, so if you see this graph, it has one minima here, and if you see it has one maxima here. So in total how many maxima and minima? One maxima, one minima. So total number of maxima plus minima कितने हो गए? The total number of maxima plus minima 2. So the answer is 2. Okay, so we drew the graph of both these functions, then we joined them, and this is the final graph. Fine, let's move on to the next question. So this is your next question. Lalit, try to do this. Anyway, so it seems we don't have any answers to this, so I'll try to solve it. So first we have to understand something about quadratic equations. Okay, understand that quadratic equation is generally of the form y equals ax square plus bx plus c. This is a general quadratic equation, and this can take two graphs. If A is positive, the graph looks something like this. If A is negative, the graph looks something like this. Okay, now understand that if A is positive, the graph opens upward, so it has only a minima. And understand that if A is less than 0, it has only a maxima. Okay, so when A is positive, only a minima exists. When A is negative, only a maxima exists. Okay, and this, the coordinate of this maxima minima is minus b upon 2a comma minus d upon 4a. This you can calculate by differentiating this function y equals ax square plus bx plus c one time. Okay, you will get the point, then you put that point into the function, you will get the value minus d by 4a. Similarly, this maxima point is also minus b upon 2a minus d by 4a. So you see the point of maxima and the point of minima, they are same. Sorry, the point of minima, the point of maxima, they are the same. But depending upon the sign of a, it could be maxima or minima. So if you see in the first function, the coefficient is positive. Okay, positive, which means this case, so only a minima will exist. Hence they have asked the minima of fx. In this case, only a maxima will exist. So hence they have asked only the maxima, and then we have to calculate the relation. So we will say that minima of fx, okay, minimum value, that is minus d upon 4a. So if you calculate minus d, it will be b square minus 4ac and hold this with negative sign upon 4 into a. This is the minimum of fx. What about maximum of gx? So let me write down gx. Minus x square minus 2cx plus b square. So maximum of gx, it would be again minus t upon 4a, which would be minus b square minus 4 into a into c upon 4 into a. Now see this, you just solve it, you'll get 4c square plus 4b square upon 4. This minus and minus will cancel out, and if you solve this, you will get 8c square with a positive sign, because this negative and this negative will become positive, minus 4b square upon 4. This is the minimum value and that is the maximum value, and we have been said that minima of fx should be greater than maxima of gx. So minima of fx is 8c square minus 4b square over 4. Maxima of fx is 4c square plus 4b square over 4. 4 and 4 will cancel out. 4c square will go here. So 8c square minus 4c square is 4. 4 will go here. 4 plus 4 is 8b square. We take out the square root on both sides. It's 4 and this will cancel out 2. So c square is greater than 2b square. It implies take the square root on both sides. If you take square root, you will have to apply a modulus. Mod c is greater than 2 mod b. Okay. Mod c is greater than not 2 root 2, because you have taken a square root. And if you see, the answer is D. Mod c is greater than mod b root 2. Okay. Fine. I hope that was clear. The key point to remember is that the maxima or the minimum value of a quadratic equation exists at minus d by 4a, and it totally depends on the coefficient, the leading coefficient, whether it will be a maxima or a minima. Next question. It is also quite simple. Try to do it, then I'll solve it. आराम से देखना है इस क्वेश्चन को. This question you can, there's a high chance that you will commit mistake. Okay, so let's do it. So fx equals mod x. Fine. So try to understand that what does the graph of mod x look like. Graph of mod x looks like this. Again, I have repetitively said that it's not necessary that for a maximum or minimum to have, the graph has to be differentiable. For example, look at this point at x equal to 0. The graph is not differentiable, still it has a minima. So by definition, minima doesn't have to do anything with differentiability, to be honest. But for very differentiable continuous and differentiable function, there are some good relations. But on top of that, you should keep your eyes open to questions which are not differentiable. For example, piecewise functions, you cannot simply do that. You cannot simply go and calculate the derivative and say, okay, this is how I have gotten it. Okay, fine. So in this question, what I'm going to do, I'm going to draw the graph and then see whether it has a maxima or minima. So for a simple modulus function, it has a minima at x equal to 0. You see the minimum value. Okay. Now for mod x, when mod x lies between 0 and 2, if you unfold it, you will get mod x lie between 2 and minus 2. But see, 0 is not included, so x not equal to 0. Okay, so x lies between minus 2 and 2 but not equal to 0, and 1 when x equal to 0. So this is the graph. So let's try to do it actually. So minus 2 to 2, minus 2 to 2, minus 2 to 2, 2 to 2. Oh, that sounds like a song. Weird. Anyway, so this 2. This is how the graph will look like. And at x equal to 0, the value is not 0, the value is somewhat 1. So now just try to see the nature. The graph was decreasing, no local maxima, no local minima. It reached 0 and there's a sudden bump here. There's a sudden bump and then it again decreased, then increased. So this is, what is this characteristic? This is a maxima. So this is a good thing. Modulus function on its own will have a minima, but now the function has been modified to actually make it look like a maxima. Okay, fine. Because the maxima, the function has to increase then decrease. So in this question, the function first increased and then decreased. So you will have a local maxima. Option number A. Option A. Let's move on to the next question. Oh, sorry. Oh. So the question is that the function is x square minus 1 upon x square plus 1 for every real number x. This is defined for r to r, not r to r. This is defined for every real number. Then the minimum value of fx is. You have to calculate the minimum. So again, one way is to do this differentiation and get the answer, and one way is to use your head. I will do it using both method, and then you will see which method is actually easy to solve. So first we will go with the standard method. You take the derivative. You will say, okay, differentiation of first, leave second, differentiation of second, leave first, equals 0. You put it 0, so you can only put the numerator 0, not the denominator. You will get 2x, as 2x is common from both. x square and x square will cancel out. 1 and minus 1 will 1 and minus 1 will be 2. So you will get x equal to 0. And if you check, this will turn out to be the point of minima. X equal to 0 will be the point of minima. Now if you put this value back here, it would be how much? It would be 0 minus 1 upon 0 plus 1. So the answer is fairly simple, minus 1. Okay, the answer we have gotten minus 1 in a pretty straightforward fashion. But what if I tell you calculate the maximum value of this function? Calculate the maximum value. Now you might think for a while, how can I calculate the maximum value? Because when you calculate the derivative, and you got only 1 point, x equal to 0, and 1 point could either be maxima or minima. How could it be maxima and minima both? So now if I tell you how to calculate the maxima, then you will get confused how to calculate the maxima, how to actually calculate the maximum. So let's try to find out the maxima of this function, and this is where the alternate method kicks in. You understand that this x square and x square will cancel out, 1 minus 1 will be 2. That's how we have got it. So let's try to calculate maxima of, okay, remember I can write it as this x square plus 1 minus 2 upon x square plus 1, which could in turn be written as 1 minus 2 upon 1 plus x square. Now you see y equals 1 minus 2 upon 1 plus x square. Now understand that this value is a constant and this is something which we are decreasing, which we are subtracting from this. And we have already proved that this value is always greater than or equal to minus 1, which is the minimum value. So we are subtracting something out of it. If we want to maximize this, we would like this thing to be minimized, because the less we subtract, the greater this whole value will become. If we want, so we want 2 plus 1 plus x square to be minimized. If we want this to be minimized, we want the numerator to be, if we want this to be minimized, we want the numerator to be maximized. And what is the maximum value of numerator when x tends to infinity? When x tends to infinity, 1 plus x square will tends to infinity, 2 upon infinity is 0, so maximum value of y is 1. So you can say that the value y lies between 1 and minus 1. Not a close sign, because the value is attainable at x equal to infinity, but you will still call it the maximum. Okay, because still it's the approaching value which you can get. Okay, so the maxima is 1 and the minima is minus 1. Next question, JEE Advanced 2016. Yeah, this question also was a nightmare. It looks cute, but this is not. Took me a lot of time. So yeah, because I gave JEE 2016. Anyway, so the question is, let f r to 0 to let f r 0 to infinity and g r to r be twice differentiable function. Oh, you guys might not be able to see it. Let me write it as this. Okay, or at least you will be able to see the question. Let f r 0 to infinity and g r to r be twice differentiable function, such that the double derivative and the double derivative of f and the double derivative of g are continuous function. Suppose the first derivative of 2 equals g2 equals 0, and the second derivative is not equal to 0, and the first derivative of 2 is also not equal to 0. Then we have to calculate the limit of fx gx f dash x g dash x. Okay, and then we will, if this limit is 1, then we have to make some conclusions. So it is evident that we can make the conclusion only from the given statement, and the given statement include f2 equals g dash f dash 2 0, and the rest of the statement is this is the statement which we have. Now understand that if I put 2 here, 2 directly here, you will get g2, which would go to 0, and f dash 2, it should go to 0. So this will be 0 by 0 form, which means we can apply L'Hopital rule here. So we will simply apply L'Hopital rule, and what this L'Hopital rule says, it says that you differentiate the numerator as well as the denominator when you find one of the 7 indeterminate forms, and one of the 7 indeterminate form is 0 by 0, which is most often encountered. Okay, so limit x tending to 0 2, we apply the L'Hopital rule, which implies the differentiation of first leave second, the differentiation of second leave first, in the denominator also the differentiation of second leave first. Okay, now you see, if you put 2 here, you will get something like this. If you put 2 here, remember f dash 2 is 0. If you put 2 here, this will go to 0 because f dash 2 is 0. Again, this will also go to 0 because f dash 2 is 0. So you will be left with limit x tending to 2 g dash f upon g dash f double dash. Now understand that you can cancel g dash and g dash. Why? Because g dash 2 is not equal to 0. So if you put the even though if it was, so this is not equal to 0. Okay, as x tends to, this is not equal to 0, so you can cancel it out. So this limit is 1. So if you now put the value of the limit, you will say no, sorry, that's f, not double dash. That's f, not the dash. So you will get f2 equals f double dash 2. So now you can write f double dash 2 minus f2 equals 1 equals 0. Now if you look at the last option, it says that fx minus f double dash x is 0 for at least 1 hour. And now we have this is what we have proved. We have proved that fx minus f double dash x equal to 0 is true for at least x equal to 2. So it is true for at least one value, and this is what the last option tries to say, that it is true for at least one value. So this is what we have. Also we have proved that f dash f2 equals f double dash 2. We simply proved it, which implies that this option is not correct. Okay, now also try to understand that f dash 2 was equal to 0, which means it could either be a maxima or a minima, which we have to verify. So it means that at x equal to 2, either it could be a maxima or a minima. So how do we verify it if it is a maxima or a minima? By double derivative. And the double derivative is f double dash 2, which is equal to f2. Now understand that the function f is defined from r to 0 to infinity. It means that the function itself is positive quantity. It means that the function itself is positive quantity. If the function is positive quantity, it means that f2 is greater than 0. If f2 is greater than 0, it means that the double derivative is also greater than 0 because they are equal. Because they are equal, so the double derivative is also greater than equal to 0. I will again repeat, since the function is always positive, f2 is always positive, which implies that f double dash 2 is always positive. So first derivative is 0, the second derivative is positive. What is this? This is a minima. This is a minima. Okay, so I hope this was clear. So the correct option is it has a local minima at x equal to 2, and fx minus f double dash x has at least one root. Okay, fine. So let's try to do the next question, and the next question is this. The question is, if fx equals this and gx equals this, then we have to, I guess this is more than one, correct? Gx has local maxima at this, fx has local maxima. I guess this is more than one, correct? Again, so I'll just hold it down so that you can at least read the question. Okay, so let's do it. So we have been given that the function is e to the power x 2 minus e to the power x minus 1 x minus e. So again, in order to see anything about f, we have to understand that we have to plot f, because this is a piecewise function. So first understand that, so this is e to the power x graph. Okay, e to the power x minus 1 graph would be, instead of having a value at here, it will have the same value at here. So the axis would shift somewhat here. So at x equal to 1, it will get the value of 1. This is y equals to e to the power x minus 1. Okay, so let's try to plot the graph finally. So we have fx equals e to the power x 2 minus e to the power x minus 1 and x minus e, and if you see this is 0 and 1, the other one is 1 and 2, and the other one is 2 and 3. So let's try plotting them one by one. So at 0 the value is 1, at 1 the value is e to the power 1. Okay, now at 1 you'll see this value would be equal to 2. At 1 this would be 1 minus 1, 1 minus 1, which is 0. So e to the power 0 is 1, 2 minus 1 is 1. So the value would be how much? Remember there is an equality here. So the value would be somewhat like this. 1, and it will go to how much? It will decrease, okay, because since there is a negative sign, and it will be strictly decreasing because e to the power x is strictly decreasing. It implies that minus e to the power x would be strictly decreasing, and same goes with e to the power x minus 1. So if you put the value of x equal to 2 here, you will get the value e to the power 2 minus 1, which is e to the power 1, 2 minus e to the power 1. So 2 minus e to the power 1, 2 minus e to the power 1, which is 2 minus 1 upon e. So I guess it's not minus 1, it's plus 1. So 2 minus e. E is 2.718, which implies this quantity would be negative. So slightly here, not here. Let's say 1 to 2. So at 2, this is 1. We can say that the value comes down here, and it is included. Okay. Now x minus e. Y equals x minus e. At the value of 2, when you have put the value of 2, it would be 2 minus e. So 2 minus e, which means it will start exactly here, because this value is 2 minus e. 2 minus e. Okay, so it will start exactly here, and then it will keep on increasing up to 3 minus e. 3 minus e is slightly positive. 3 minus 2.718. So it is slightly positive, but still less than 1. So this is 3 minus e. So you see the graph. Okay, so you see there's I see a local maxima here, I see a local minima here. Okay, so the question is, fx has no local maxima. No, fx has a local maxima, and the local maxima is this. Okay, the other question is, fx has a local maxima at x equal to 1, true, and a local minima at x equal to 2, true. So you see it has a local maxima at x equal to 1 and local minima at x equal to 2. So this option is correct. And now we have to see gx. So now you see that if you try to see gx is 0 to x ft. Now you apply the Newton-Leibniz theorem, and you'll see that the derivative of x g dash x is, first differentiate x, which is 1, and then put it here, then 0. So the answer is x. So basically the graph of derivative of x gx is nothing but fx x only. So this is also the graph of fx, or this is the graph of g dash x. Okay, now if you see the derivative is increasing, it means the function is increasing for g. G dash x is increasing. Okay, it was increasing, then it is decreasing. So obviously increasing, then it is decreasing. Increasing function, then after decreasing function. You see this is a decreasing function. No, it's not decreasing. My bad. Actually, I have to look at the derivative. The derivative is positive here, which means increasing. The derivative is again positive here, which means the function is still increasing. Okay, the function is still increasing. Like it's like this and like this. This is still increasing. You wouldn't say that this is a maximum or something. But you see at here the graph changes from derivative increasing positive to negative, which means the derivative goes from increasing to decreasing, and at here also decreasing to increasing. It means that it encounters increasing to decreasing, a maxima here and a minima here. Okay, maxima here and a minima here. So the options are, gx has a local maxima at x equal to 1 plus log 2. Yeah, this is actually 1 plus log 2. because if you put log 2 here, 1 plus log 2, this would be exactly 0. So it has a maxima at local 1 plus log 2 and a local minima at x equal to e, and this point is x equal to e. Yeah, so the correct options are A and B. So the correct options are A and B. Okay, the correct options are A and B. Fine, I hope so. Basically we just had to draw the graph. So let's try to do the next question. I guess we are done with today. I guess this is all we have. So we have done all the questions of maxima and minima from JEE Advanced paper, and thanks a lot for being with me and watching this lecture. This is my humble request. If you like this video, yeah, subscribe to kar dena. Please subscribe to the channel because people are really working hard. And if you want to take a plus course, plus subscription, use this promo code SK01 to get 10% extra discount. ठीक है, ओके मैं चलता हूँ, बाय.